Hello. Welcome.
Good evening.
Evening and or morning and or other time of day that is relevant to you. We got Charles already jumping in, waving hi. There we go. Hey
So fun.
Charles. Uh how's it going? It's late for you, right? You're I forget exactly what. You're on like the East
East
Coast or
Coast, all right?
Eastern time or something like that. I think you're in Canada, right? While Charles is remembering where he is, and there's like a stream delay. Hello, I'm Dan Reynolds. I work as a technical sound designer, technical audio designer. Someday we'll figure out what the real difference between audio and sound is.
Mhm.
Um, and I'm joined by Eric Buchholz, who's also working as a technical audio designer. Look
Yeah.
at that.
The way I kind of think of it, and this probably isn't universal, but like sound kind of refers to like your sound effects, your foley, your ambience, and all that stuff. Whereas like then there's music,
Yeah.
um, which could be like separate from sound, but it's all we're all one family here, all sounds.
Yeah, it's an interesting thing because I think a lot of this distinction has been driven by the film and television industry, which
Sure.
in the US is heavily unionized, and unions are very good at defining roles. Like that's a huge part of the
Hmm.
union process is determining the sort of scope of someone's work. And so I think we've kind of codified these as distinct parts of the soundtrack representation.
Sure.
Sound recording, production sound, sound mixing, sound editing, and sound design, which I think was like a late addition. Was that coined by Ben Burt? I forget. It was coined by some famous sound designer. Um, but yeah, and I think that that's sort of an interesting development. I feel that's very 20th century because if you look back at the beginning of the multimedia experience, sound and music were intertwined. You had sound effects that were being played and performed by
Yeah.
instruments,
Yeah.
and I there's like a great two-part clip. I don't even know what it's from. It's from some larger presentation, but it talks about Treg Brown, who was editor at Warner Brothers in the sort of early days of
Mm.
the Warner Brothers cartoon era, and kind of worked at like while Carl Starling was also working there, and so and I think one of the things that he kind of revolutionized the way that my impression from from the documentary presentation was that he was like a big part of exploring sound as a metaphor, like sound recordings as a metaphor for other expressions of action
Mm.
on screen. So like, someone running really fast, they might have like a airplane like
Okay.
fly by, and
Yeah.
that's like total like that's not what it sounds like when someone's running, that's just, but it's like a great expression of like speed, and so and I think that sort of brought uh the sort of that kind of work, whether he I don't know if, I mean, I know he's a pioneer in that, but I don't know if he was like the first,
Hmm.
but that's sort of like that transition from uh like the merry melodies kind of thing, where it was all sounds were basically the orchestra playing, right, and
Yeah.
then moving over to like sound recordings. And I imagine that has to be driven by a technology, right, like having soundtracks on film, like that was a big, obviously, this huge part of that transition process, you know before having the soundtrack on film, right? You had the sort of accompaniment that was like the player in the theater. So, um, so yeah, I wonder.
Yeah.
I wonder when they became so distinct from each other that they were like codified jobs, you know? Because Trent
Yeah.
Brown wasn't considered a sound designer; he was like a film editor, but he did a lot with the sound
Mm.
track, and so yeah,
Yeah, and nowadays we see job postings. We have like music designer positions and audio designer positions, sound designer positions, and it's like
yeah,
there's
sound
large.
artist
Yeah,
or
there's a lot
audio.
of
I think
overlap
audio
there.
artist is like EA does the audio artist. That's always an interesting one.
It's just mincing words at that point.
Well, yeah, and I think I mean I don't know 100% what the driver is behind that. I've always assumed that like EA using artist instead of designer was because it came from like a different department budget or something like that.
Yeah.
But yeah, that's it's an interesting space, and I get frustrated sometimes because I feel very strongly that they are intertwined. That like orchestration, that uh, composition, in particular instrumentation, is a huge part of the sound design process, and that should be considered sound design in the same way that you're managing the harmonic content, the the timbre of your sort of audio presentation. Uh, yeah.
Yeah.
So I think our because originally I was a technical sound designer at Epic, and then they changed all the titles to audio designer,
Hmm.
which was interesting.
Do you
And
remember
so
why they did
I,
that?
I don't know the whole reason. I think that it's because of exactly what we're talking about, where sound is somehow distinct from music, but audio is somehow like an umbrella term for both.
Yeah.
So yeah, and then we're all muncing everything up. Is that a word? Speaking of words, is like the etymology of those gets really chaotic, because we talk about sound and graphics, which is not that's not how it should. That's not the pairing. It's sonics and graphics, right?
Hmm.
But sonics is not like we don't. It's not like a noun that we use. Like it's confuses people. Yeah, for anyone keeping track at home, I have a degree in English. There you go. So I can nerd out about words a little bit. Yeah, there you are. Charles is in Montreal, so there you go. Drifting in and out. I imagine that is like sleep. Not that you're doing something else, but you're just sort of like at the edge of unconsciousness, and, and this is playing in the background. Yeah. All right. Yeah.
So what you
So
got?
what do I got? Yeah. So what we're doing today is kind of built. I was kind of building off of the harmony node that I made last time. I was thinking about that because there's one thing that I've used in the past. I've used like in blueprints. I did like a procedural music presentation back in I think 2017 with for a organization over in England called Procedural Audio Now, and that was a presentation that both Aaron and I did. And he talked about what it's like to go from like Max into blueprints.
Mm.
What's the sort of like what are the analogs and stuff like that?
Yeah.
And then I did a sort of application of a procedural music design using the old synth components and stuff. You can still find that on YouTube. But one of the things that I didn't there's some interesting ideas that I implemented. One of the ones that I wanted to implement that I didn't really quite implement was this idea of Markov chains. And I've linked a video from Veritasium about Markov chains if you want to sort of explore this. But basically, Markov chains are an a probability of transition from state to state, right? So it's like if something is, you know, well, in the case of music, let's say if I am currently on a one chord. By the way, this is going to be a very music theory.
Great.
Again, I have an English degree. I did not do well in music theory, so
I took music theory, 2 years of music school, and it did not stick. I mean, some of it stuck, but I didn't
it's
use it as much as they like say that you're going to use it.
yeah,
It's a tool. It's not
it's a
like
yeah,
a
exactly. It's a very specific thing. It's a very specific subject, and it's a very like the I feel the way most music schools teach it is very specific, and I actually disagree with a lot of the approaches that they take. I did actually teach music theory, and when I taught it, I took a very different kind of slant to it. But I was also teaching in like a vocational program that was focused on like sound design and stuff like that. So, I sort of used music theory as like a tool, like use it a toolbox basically
yeah.
of ideas and scaffolding that you can sort of build upon. Also because it's a complete construct. And what I sort of the way that I would present music theory is an ongoing discussion about how sound sounds, like how sound sounds consonant or dissonant, and what does that mean, um, and it's something that doesn't end, right? It's just like we keep having these conversations, and the reason I use that framing device is because I was teaching like a lot of beat makers who were like, but like my idol doesn't read music, and I'm like, it's not music literacy, it's different from music literacy. And I would sort of assert that like even people who don't read music or haven't read any music theory books who make music have a music theory, and they have developed on their own. Hey, when I make this hand chord or hand gesture, or it sounds good if I do this one afterward, like that kind of stuff is
Yeah.
basically music theory. And
It's just a framework of thinking about it,
yeah,
right?
exactly.
It can come from wherever. You can develop your own sort of theories and stuff, but um, yeah, what they teach in school is a small slice of
Yeah.
all of the possibilities that are out there.
You know what got me is the school that so I jumped in when I was at university. Even though I wasn't in the music school, I took some music courses. The idea that maybe I would switch over or add on, I was kind of one of those people. I was like one course away from like a computer science minor, and I was like
Sure.
2 courses away from a Japanese major. Like it's just add-ons. In fact, they just kicked me out. They were like, "You have spent too long in school," and I was like, "Give me one more semester, and I'll finish with a degree." And they're like, "All right, one more semester." But the now I got sidetracked there. What were we talking about?
Markov chains.
Well, okay, yeah. So bring it back down. Yeah. So Cody is like, it wasn't inspired by the Veritasium video, but I wanted to like validate my understanding of Markov chains by like watching the video. So that helped. But yeah, it was as I expected. I think the difference is, and this is sort of like if there's like an old video of me doing like a presentation on data oriented design, as I called it, which is now I understand to be called data driven design. And it's just where the data is. That's all it is. That's just where the data comes from. And so a lot of Markov chains are sort of developed to understand complex systems as an analysis of things that happen. So in other words, they sort of analyze data, they develop a Markov chain as a theory for how complex systems behave, and then they will sort of figure out what thresholds help them to control that system behavior in certain ways, right? So that's how Markov chains were sort of developed as an analysis. If you look at the Veritasium videos, great. It talks about the history of it, and it's basically word analysis. It's like letter analysis. It's like predictive text
Okay.
is like the origins of Markov chains. So, but what we can do is we can use the model, and we can create. We can sort of inject our own probabilities, and I'll get in. I guess I'll get into a little bit about Markov chains. We inject our own probabilities to create our own system behavior, because when we're doing procedural music, what we're trying to do is we're trying to constrain and control probabilities, stochastic design, as we call it, right? And so, if you look at Markov chains basically, in our case, let's say we want to transition from a one chord to another chord, and we have 7, let's just keep it simple, diatonic modes or diatonic scale degrees. If you're going to go for one chord to another chord in your diatonic scale, what is the probability that you would transition to any of them, right? And so you might say, well, maybe the probability is high that I would go to another one chord or a 4 chord or a 5 chord. Maybe the probability is less as high, maybe medium probability, that I would go to a 3 chord or a 6 chord, right? And maybe even a little bit less, you'd go to a 2 chord or a 7 chord, or maybe the 7 chord be super less, So it's like,
Sure.
you think about the probability that you would transition from one scale degree to another scale degree, and then you can create this probability table. And so let me. Is everyone on board with that? We got
Yeah,
4
let's take a
people.
look.
Yeah. So let me share my screen. Entire screen. Oh wait. Oh, I forgot to check my audio. Hold on a second. Just give me a second. And Eric will say interesting things.
Are you just gonna leave me?
No. It's I remember. Oh, I was doing like a feedback thing. Okay, hold on a second.
Right, from last week.
Yeah, so I've got
Gotcha.
AES channel. Okay, so the input. Hold on, I can check. I'm gonna change my audio settings. This is potentially very risky. Okay, that is the input. Oh. Oh, I see what I need to do. Okay, hold on a second. Sorry, what I need to do is I need to send the audio out to my headphones. And I think that got reset. Otherwise, you hear the feedback.
Right. Yeah.
And it's just these new sound settings. They have you have to go into like a secondary menu for like the actual device management. Here we are. Apologies. Okay. Yes, thank you, JetBrains. Go away. This JetBrains notification is right on top of the bar. What are you doing there, JetBrains? I don't care about you right now. What the heck? Yeah, thanks.
Got Steven in the chat. What's up? How's it going?
Yeah. Who likes JetBrains here?
I do.
I do. I actually do like it.
Yeah, I really do like the UI over Visual Studio.
I like the UI over Vax. Sorry, Vax. I don't know if there are any Vax users in the chat.
No.
Sorry, I need to swap channels in my headphones. And
it seems like the times that I've used Visual Studio, it's like you click on something and it will just not respond, and then you wait a bit, then you click on something else and then it doesn't respond. And that's just been, that kind of summarizes my whole experience. um, I don't
Well,
know.
I think something that okay, yeah, here we go. Now I'm set up correctly here.
Okay.
Apologies. Yeah, so it's basically so just for people at home, so you know, this is one of those dumb things because the host that I'm using is web based. When it outputs audio, it's included in the desktop audio. So when I share sound, when I share my screen, it shares the output of the audio. So I have to route it specifically to my headphones, which I've just done. And for whatever reason, Windows did a thing and shut that device off. So it was disabled and then it was no longer selected and defaulted back to my system default. So dumb audio person
Hooray for
things.
Windows.
Well, this is why any audio people start a Zoom call and no one can hear what they're saying because we have this weird complex setup. Windows, everything's trying to be very like automatic and friendly, because because most people don't know what all that is. But then they invariably make choices that are infuriating. So,
Oh, you don't want spatial audio in your Zoom call?
no, I don't want spatial audio. Okay, so here's the test. I'm sharing sound. I'm sharing my screen. Hold on, actually, I didn't bring it up. I'm sharing my screen. I'm sharing sound. And do people hear slapback? Or I guess it would be you, Eric.
Yeah, I'm
you
testing and not hearing anything. So
I don't hear
good.
anything.
Can you play your sound or
Yep.
something?
Yeah, that's good. Good one.
Sounds good.
You can hear it?
Yep.
Good. Okay, we got the weird. I'll get into this. This is a pretty complex design. There's a lot of stuff at work, a lot of procedural music ideas at work here. But yeah. So let me just. Okay. So I was like thinking to myself, okay. I've wanted to do like an episode where we talk about node config. I've been using it more and more just for myself and for at work. So node config, for folks who aren't familiar, node config is a new feature of MetaSounds. It's kind of an early access feature. Oh, awesome! Stephen verifies that there's no slapback, so we did it right. But yeah, node config. Effectively, node config allows you to sort of sideload data into your MetaSound. So if we go to the node in question, oh my god, there's so much going on here. The node in question, where is the node? Here we go. You'll see over here on the left, I have a data asset reference.
Wow.
So
everybody ooh and ah.
Ooh. Ooh. So this is exciting. I think this, if anything, I think the cool takeaway, if you're like an Unreal dev, I think the cool takeaway here is this idea that you could effectively sideload a huge amount of data into your MetaSound node instance without it being an input, without it sort of cluttering up the inputs. And we'll look at we'll look at what's behind the hood here, because the the amount of data I'm stuffing through it would be a lot of pins, let's just say, and it would be very confusing to manage because we have only plain old data types here.
So, and you're probably going to dive into this, but just to kind of elaborate on, when you say sideload the data, what do you mean by that, and like why should people be excited? I guess would be maybe something.
Yeah. So yeah, okay, so there's lots. Basically it comes down to the core of how MetaSound architecture is built, and the core architecture of MetaSounds is separated from the normal Unreal object architecture, and there's a lot of good reasons for this, but one of the main reasons is not having to be intertwined with Unreal's um, memory management system, which only functions effectively on the game thread.
Mhm.
Metasounds need to render as tasks separated from the game thread. And so and that gives like that makes metasounds more performant. That means metasounds aren't going to impact the game thread unless there's like complete CPU saturation. Then anything could impact the game thread at that stage. And so, but then there's also this sort of possibility that metasounds, the core part of metasounds, can be divorced from Unreal entirely, and could potentially be a feature outside of Unreal. So those are all really cool, but what that means is you kind of have like this brain blood barrier where only specific data can be moved from gameplay into the meta sound, and that's for two reasons. One is that the types of data in the meta sound uh, cannot be based around UObject architecture. And so that means they can't have references to UObject classes, blueprints, that sort of stuff. You can't pass that in. And so if you want to intake data that's on those, you have to do something really complicated, like the sound wave. The sound wave references.
Right.
They actually create a proxy object, a stand-in object that represents the sound wave inside the meta sound and has separated out all the sort of UObject stuff and has just sent over like the bulk data.
Okay.
And so that's like a great example of how it's quite a bit of work sometimes to, if you want to like take something that's kind of heavyweight in terms of the data that it stores. An audio file obviously is a lot of data on it. And to have that accessible to your metasound graph. But here's the thing: is that metasounds compile or have there's like a sort of point during the creation of the metasound that it is accessible from the game thread, and so basically what you see over here on the left side is a U struct. A U struct is an Unreal struct, Unreal flavor of struct, and the Unreal's flavor of struct itself can't live in the metasound, but it can be associated with your metasound node, and that's how node configuration works. It allows you to sort of define a bunch of data that can reference gameplay data, and then on the metasounds node's creation, when that node gets created, it will sort of request. It'll call a function on that struct, and it will, and then you basically implement some way to pass the data over. So in my case, I actually did have to create a proxy data struct, but it wasn't like really complicated to mirror those two things. And so in my case, it's just a matrix. I've just had to create a matrix and then pass over to another matrix type, a more lightweight matrix type.
This data then is essentially fixed from when you start the metasound. You can't pass runtime data through this data asset. You would have to run it through an input like normal.
Yep.
Cool.
But the data is then usable. And because it's passed over to the metasound, it doesn't have to be static. It could be dynamic, right? It could be the initial parameters of this data. The metasound node could affect it, change it in some ways. But what I think is the power here is that there's actually quite a lot of times when your input is just set once. Especially, let's say, if you're inputting an array, right? You're not. Metasounds, first of all, are kind of finicky to work with arrays. There's a whole reason behind that. But you can imagine that most of the times you're just setting that value and then you're sort of forgetting it, you know.
Mhm.
And I think a lot of input parameters are treated that way. Um, and s- uh, and then there's sort of like the types that you do want to be very dynamic, right? In my case, right, I wanted to implement this probability system, but every input value had multiple possible output values with their own probability amounts, right?
Mm.
So if I wanted to go from my one chord to another chord, I have to have 7 values stored for that chord. And so for 1 through 7, I basically need a table that's 7 by 7 sized. And in order to implement that, because my probabilities are just float values, which is a plain old data type, I could have implemented it with 7 arrays,
Sure, yeah.
right?
I was
But
just thinking, like, there are ways you could do
you
this,
could do
but
it.
this
It's
is a lot like
it's kind of ugly. Yeah,
more
it's
compact and data driven.
well, and then here's the other fun part, because I could have implemented the 7 by 7 array directly into the struct here, right?
Mm.
Instead, I decided to implement my array into or my table into a data asset, which means that the data asset can be authored independently of the meta sound, and it could be portable and reused over and over again, right? Like for example, this configuration data is associated specifically with this instance of this meta sound node.
Mhm.
If I click another instance, then it may, it's going to have maybe some other data. This in this case, it does have some other data. So in other words, but maybe if I go to another one, and I think I do have another one here. That's the first one. So I'm reusing it. So by using the data assets, just like data assets in gameplay, they allow you to make your data portable, right? And you can reuse
Yeah.
it over and over again. And uh, so yeah, I thought that would ease the authoring effort. And then I thought it could be fun, and we'll see if we can get to this. But I thought it could be fun to implement a like editor utility to author the data on there, sort of nicify it, because matrices look terrible in the standard U property reflection. They're like really ugly because you just have like a big list that you have to expand every element into its subsequent
Yeah.
elements, and then it's just yeah. Because there isn't actually a matrix. There isn't property U property reflection support for an actual matrix.
Mm.
And so it always has to be like an array of an array or something like that.
Yeah.
So yeah, so that's the sort of premise. And then I kind of went ham here, man. I did. I kind of went went a little
Yeah.
extra. I actually think I might have a simplified test here. I think I did another one. Is this a viable one? I don't remember. Oh, this is all red.
Much
What was that?
simpler.
Let me do the.
Do the right click update node class. Oh, it's not there.
Yeah, I think this just died. Um, but I could do. I think it's just the name probably actually. Oh, I did scale. Well, you know what happened was, yeah, it's basically the same one. Look at that. Look at that.
Nice.
Oh, this default should be 0. That's always one of those finicky things when you're working with music, is if you decide to count from 1 or count from
Yeah.
yeah. Uh, And when you're dealing with arrays and array elements and traversing arrays, it tends to be easier to just count by 0. I think this implementation is, if I remember, it's like an arpeggiation. So, but the again, the Markov chain, you don't have to do the node configuration to apply this technique. This technique, it's just that it can be kind of dense with the data.
Sure.
But all you have to do is think about your data in that sort of table, as like a very simplified version. I should say, I actually should mention this, is that um, in my case, I'm only solving for pairings. Let's see what this sounds like. I think this is fixed. I don't know. It's just okay. I don't know what's I don't really know what's going on here. To be honest with you. Anyway, so I just solved for pairings, which is sort of like the simplest version of like a Markov chain described system, which is
Okay.
to say that like what is the frequency, or what is the probability that you would transition from 1 to 1, from 1 to 2, and that's the only thing you care about is that one transition. Because if you wanted to go deeper, you would also think about what it would mean to then transition to the next one, right? And then your graph explodes because you're adding another dimension
Yeah.
to your matrix, right? And then it'd be like 3-dimensional matrix, and it just goes up from there. If you're just like, what is the like probability chain of this sequence of of chords, and I think that loses something, because that is something that I think that's the kind of data I think you would get more from analysis
Mm.
than you would sort of drive by your intuition or your own sort of design methodology or whatever. And so that's kind of where I would draw the line. But if you were to sort of go deep on this, that is kind of the genesis of a lot of I don't know how you'd call it, like AI music, but it's not quite the same thing as a neural network, but it's like a Markov chain that's like very like several links deep, could from analysis could be used to create that kind of experience, we'll call it.
Yeah.
Someone pointed out in the my long form video that it sounds procedural, and it's like it kind of does. And I think there is you part of there's two things that work there, and when we get into the sort of nuts and bolts of this particular metasound implementation, is that when you're trying to account for more variations, you you're opening up the constraints, and that results in a more generic overall system design. And that is going to be the constant tension. What you're going to want to think about if you're like a composer and you're working on a project, and you're like, what, how do I want to deal with this sort of problem space? You're going to want to probably think more about like the range of your constraints in the context you're going to utilize this system, right? And so if it's like, oh, I'm going to be using this system, but I'm going to be using it maybe just in this one area of like the game project or whatever, then you can have a ton of constraints and it's going to sound a lot more unique and a lot more original. But if you're like, this can happen anywhere, then it's probably going to, unless you're giving it very unique input. For example, in this case, I am just literally synthesizing everything, right? The drums are the only things that aren't synthesized. And that was just because I wanted like a steady musical backbeat. But like everything else is synthesized. That is an idea that is very specific to this open, like the openness of my melody and harmonic generation. But you could use this same system, not this like chord system, but you could use like a Markov chain approach to sequencing stems, right? You could have fully recorded orchestra stems in for your project, and then you've broken it up into little chunks, and then you've designed how they sequence from one to another, and that is a way to sort of inject more of a uniqueness, to make it feel less procedural, more specific to your
Yeah.
system. I think you see this kind of approach in a lot of very like open um, uh, procedural music implementations. Unfortunately, I don't have any like on hand, but I like my like, and I don't know for the specifics, but like I remember playing Breath of the Wild and just sort of feeling like some of the piano music, the sort of background that's when you're in the overworld or whatever,
Mhm.
feels like it's uh it feels like the space, but it's also very, you can feel like it's also just ambient procedurality, and it's not like you know the constructed soundtrack. But again, I don't know the specifics of that implementation.
Yeah, I think Breath of the Wild. I'm trying to remember, but I want to say that it was like composed through music for even
Mm,
like the ambient piano stuff.
wow,
Um, I
it
remember
doesn't feel like
watching.
it.
No,
Yeah,
it's very spread out, and there were a lot of like music analysis videos on YouTube where
yeah.
people are like removing the silences between it, and like
Oh,
analyzing the whole
interesting.
structure and like like it's actually a piece of
Is
music.
it
They
pretty
just
consistent?
uh yeah, it's
That's
like a whole
interesting.
piece of music if you like
Yeah.
remove all the breaks from it. I I don't want to talk too much about that because
No, no, no. Yeah.
my memory isn't the best on all that. But check it out because yeah, there's some cool stuff they do with the music there.
Well, that could be an example of an application of this approach, right? For
Mhm.
example, let's say you've got a bunch of ambient piano textures, we call them, right? And they have this sort of uh, background quality where they sort of drift in and out, like Charles. And
Okay? I was like, what?
the
Got to
you
see if
could
he's
think of
listening.
you could think about the transitions harmonically, right? You could be like, okay, that's actually something that I did in this sequence, or this design here. Is that one of the things that helped me was structurally I end up changing the mode like every 8 bars or something like that.
Hmm.
Um, because it kind of keeps it feeling a little fresh, and that's something that you can that I drive by a harmonic transition map. And so that's something you could absolutely apply to that sort of technique, where it's like, oh, I've got, you know a whole array of like Ionian textures and Dorian textures and
Sure.
Phrygian, and you go through the whole thing, and then you can sort of have these contextual parameters that may influence it. Let's say where you are in the environment, that sort of thing could be one of those drivers. But then also the sort of probability that you would transition, can help keep that sequence fresh and feeling sort of new and engaging every time.
Hmm.
So
Do you want to just let it play for a bit?
yeah,
Maybe
should we do that?
listen for a bit and then talk over it. I don't know. Like,
Is that it might be a little loud
yeah, it's a bit
here.
loud.
Let me just do cheat. Just do a little cheat. How's that? Is that better, or should I go a
Yeah,
little bit
I think
lower?
that's better. I mean, ask the folks in chat, but
There we go.
It's better. For
Can you
me.
hear me?
Yeah, sounds
Can you
great
hear
to
the
me.
song? You know what's funny is that there you go. There's a modal
Nice.
change. One of the things that I think is kind of humorous about long plays of this system is that it tends toward a Locrian mode a lot more than I would.
It likes the dark stuff.
Yeah. Yeah. But so this section over here, maybe I'll just start talking about it. This section over here is the modal change.
And that's, you said every 8 bars, right?
Yeah, and it does more than modal change. It does a seed change. So I generate 3 seeds, and then I generate a new mode, and the 3 seeds are used as an ABAC seed structure, and so that's how you get repetitions in the structure. So we've talked about this before, but like one of the ways to create musicality as I speak over like maybe the least musical.
Like, it's actually grooving pretty good right there. I'm listening. I'm trying to tune you out so I can hear the music.
But is to use seeds, and the seeds allow you to create determinism in your randomization. But in this case, I'm actually randomizing the seeds every 8 bars, and so I have 3 seeds that I use and I switch between them. You can see here, this is A, then it's B, and then it's A, and then it's C. There's C, and so this is being broadcast out to all of the random nodes. Any node that supports seed input, it has this value being put into it. And so what that means is that the A's have repetitions. All the rhythms, all the sort of melodic selections, harmonic selections are all consistent. And the harmonic movement is actually a half note, or twice this duration. And so yeah, that's a way to sort of get a more macro structure to your composition. If I wanted to take it to the next level, I would actually return to previous seed sets, so that I could sort of increase that like A B A C kind of
have long form.
Yeah, exactly.
Symphony form.
Yeah, exactly.
Sonata.
Yeah, there's sonata form. Everyone remember their sonata form.
I do not.
Oh goodness. Okay, so that's what this part is doing, and then this section is doing the melody generation. And what happens is I get this seed. Oh, I forgot to set the seed here. Oh, okay. Well, there's Dan forgot to set the seed there, and I forgot to set the refresh rate reset. Well, so Dan is a liar. Anyway, this is setting how long the notes are, the pulses.
Okay.
And it's setting how long the melodic count is for. And so what you get here is I actually do 2 to the power of whatever values this spits out. So the lowest would be 4 here, and then the highest would be 8. And the lowest would be 1 here, and the highest would be 2 here, 2 here. And then I multiply them together. So whatever this, basically what it is this, if this is I guess I'd prefer to do it like that. Anyway, I guess what happens is this is shorter if this is shorter or smaller, larger fractions, right? Because the number the number is lower because it's quarter notes or so. Or no, this is BA 1, 4. Hold on a second. What was I thinking here? Okay, well, I think what I meant to do was across like this. So 3 would be higher, and you would get more counts for longer or for shorter notes and shorter counts for longer notes. Anyway, it was late. It was late, people.
Just go with the flow.
Just go with the flow. And then I'm using this is why I changed the name, because originally I used it for chord sequencing, but I was like, hey, scale degree is a scale degree. I can use it for melody design as well. And so I made a new table that was just for melody. We'll take a look at that table later, but so that's how it's choosing the scale degree. And then what I do is I split it up into 4 again, because this actually goes to another concept I actually learned from Aaron, but is something I think that most people would intuit if they were designing a system, and that is thinking about beats, pulses as strong and weak pulses. And so if you think of like a traditional 4x4 structure, or like a common time step structure, typically that 1 is that like strong pulse in your bar, right? And then the 3rd is like the sort of secondary strong pulse, and then 2 and 4 tend to not be as strong in terms of the pulse. And if you think about the probability that you would have a subdivision at that point in the phrase, it depends on the strength of the pulse, right? So it's less likely that you would have a note division occur on like the 2 beat, right? Like that, it creates usually like this weird off-kilter, like forward, like anticipatory feel, which is very difficult to define and execute well. This sort of anticipatory beat, and that kind of thing usually doesn't happen around the 2 beat. Usually happens around the 3 beat because that's a stronger beat, and so pushing that, actually you feel like, oh, okay, it's happening, and then we're sort of pushing forward. But when it happens on the 2, it feels like you're stumbling, and so and then the other thing is that usually with melodic sequencing, you would find yourself more likely hearing chord tones on strong pulses, and less likely to hear chord tones, or more likely to hear passing tones, I should say, on weak pulses. And so, whilst I didn't implement a passing tone system, but I have implemented passing tone systems in the past, I sort of just approximated this idea, and you can kind of see that I've got probability of, these are all seed driven. Oh, where'd my seed go? Okay, yeah, something happened and my seed disappeared. Here it is, my seed's here. Anyway, the trigger filters here are using these probabilities that, in other words, the likelihood that you would see a pass through on a strong pulse is higher than you would on a weak pulse. And I favored 1, and I favored 3 and 4, actually. 4 I felt was more interesting pulse than 2. And that's where you go, that like dun 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 that just happened, like that happened because it was
pick up
passing
into the
through
next
there.
bar.
Yeah, exactly. And then here you can see I'm actually swapping between chord tones or non-chord tones. And I shouldn't say non-chord tones, I should say all tones. So this one's like full spectrum, but you're only given chord tones on these strong pulses, and that's what you see here. Is this trigger route here? This is the chord tone and the non-chord tone. And so then I just pass this through to a value set, and by the way, this is these scale degrees are used. You can see here, the scale degree is basically driving the value from the array, and then this is a quantizer. This is quantizing the output to a chord tone or not. And so in other words, this will generate what it generates, and then it'll snap to a chord tone. And then we have this is an octave switcher. So every time the seed refreshes, it'll pick a different octave for the melody. So it just boosts it up. It's just octaves 4 through 7 multiplied by 12, and you add it to the value coming out. And then it's the MIDI note, and then you're switching over to a frequency, and then you're sending that frequency to a sawtooth wave. And I got an LFO that's driven by an envelope to give the LFO a little bit of interest and movement. And then what I have here is an ADSR envelope for the melody. And the attack, decay, and release timings are all dependent on a random value. So that's how you get these like short moments where it's just like the decay is real short, and you get these sort of like boop 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 pick pick kind of things, and then you get these long ones for other melodies, because every refresh, this is every 8 bars, it refreshes, the seeds refresh, and so it'll pick a new duration for the these values. And in this case, I played around with actually ranges originally, and then I decided I didn't like it because when you give a range, if you're just doing a straight probability range, then it's equal opportunity for all values. If you're doing like a float range from like say 0.2 to 0.8, then it could be anything in between also, and that's not interesting. And so what I ended up doing was sort of hand-picking some duration values that I preferred, and then sort of adjusting the ranges based off of this integer value generated. So you hear like a plucky sound, and then sometimes it's like a longer sound. And then passing it through a filter, just sort of some sound design. I've got a stereo panner that's sort of swirling around. Now a little delay, a little reverb. Got to do your reverb. No one will take it seriously without reverb. So here's my chords, and I just have some triangle waves passing through a state variable filter just to sort of soften them, kind of the same way as I'm doing up here. But if we look at the here's the chord generation. So down here is the chord generation. This is the mode. Let's say it's the bass mode key offset. This is just basically set on start. But then down here, you'll see I got my BPM coming in, and I've got my steady pulse, and I'm just counting. I'm just resetting 4, so I'm always generating 4 chords. And then this, I just have the chord degree that I pick, and then the previous chord degree as the input. So it basically has this nice little cycle here. This is the seed that changes. This is what I was referring to before, the seed that gets updated. And so I get this chord degree, and here I'm doing some the bass. I'm taking the bass mode variable, which is moved by the big seed change. Remember, I meant that modal shift that happens every 8 bars. And then that's an offset basically of the bass mode that's selected here. And then the chord degree is the sort of updated thing, and it's basically so the modal shift provides an array that's based off of a mode, so it spits out the scale degrees of the given mode, and then the chord degree is basically a selector on that array, right? So you have intervals that can be selected from,
Mhm.
and then you have you're just it's an index. It's just an index into it, 0 through 6. And so then that's passing through the harmony mode that I made last week or whatever, the week before last or whatever it was, where you sort of provide the melody note, the chord root, the mode, and then spread. I'm just sort of randomizing the spread to sort of keep it interesting. And the only thing that's different here is that the melody note is captured by this rhythm. So in other words, this rhythm reset, it doesn't happen every time the melody tries to play. I mean, so here the melody it's about every other one at this stage. It's based off that count. And so the count that resets here, and so what you get is a chord that persists across multiple melody notes. But what happens as a result is you get the shape constrained to this particular rhythm.
Sure.
And so anyway, pass the melody note in, it spits out the root, third, fifth, and seventh note, convert it to frequency, and then you go. And then down here, I just have I've got a bass. I forgot about this. I got a bass sine wave, and it's just what I did is I took the root output, I modulate it by 12, so a whole octave, and then what happens is that reduces it to the very first octave, right? And then I just offset it by 33 octaves, so it's down on the left side of the piano, and then so I get a consistent, harmonically appropriate bass note. And
you gotta randomly choose the 7th or something every now and then. Just get those.
Maybe the
inversions.
5th. Yeah, I don't know. Yeah, it's a good
Get
point.
some
Yeah,
funky. Yeah.
we could do that. Yeah, it's I don't know about the 7th. Bass and 7th. That's wacky.
Yeah, I was being wacky. But,
yeah, that's pretty wacky.
yeah,
Anyway, the bass
other
has
wacky ideas.
the bass
got
is a very
plenty of
simple part, and it's just rhythmically supportive of this wave player, which is literally just playing the same drum loop over and over again.
Yeah, it's starting to grate on the ears a little bit now, but
yeah. Anyway, so that's the whole structure. This will be on the quiz. Are there any questions? Oh, there's a bunch of questions.
yeah, you got a few.
Let's see. Is the diatonic? Okay, sorry. Here it was. Is the diatonic harmony node a sub patch? I made my own C++ node. I will get into it tonight. Yes. Welcome to the stream, Johannes. Johanna. I don't know how. I'm sorry. I apologize if I mispronounce your name. Angelite's just like, are you on 5.6? Oh yeah. Is the spectrogram new? It's, I don't know when it was added, but you can just add. There's all the scopes are in here in this upper right hand corner menu. And I was like, why haven't I added this to my setup? So yes, it's new for me. We'll say that.
I want to say it's like 5.5 maybe.
Nice. Yeah, it's awesome. I love having it. Thank you, Angela. That's a very nice thing to say. Not too late. Charles is on fire. And Steven is screaming. Cody is hyped. Cool.
So now you got to add some key modulation. You know, every so often you got to circle the fifths or.
Yeah, and that would be an easy one, I think. Again, that could be that could be driven by scale degree. Let's take a look at the tables real quick here, just so you know what
I'm totally joking. Just by the way, trying to be funny, but it's funny you think I'm serious.
Well, so here's what I'm talking about. This is exactly. It's not a great editing experience, but it's better than inside the meta sound. And you can sign it here. I just have one. It's literally just a 7x7 table. This would definitely be expressed better in a table. And I actually attempted to make a little. Hold on a second. Here we go. Let's put this guy over here. Two over here. There we go. I actually attempted to make a widget to edit it. There we go. Over here like this. Whoops. There we go. Like that. Not bad looking, right?
Mm-hmm.
I even did the. Well. I changed my type, so that's why that's all messed
Ooh.
up here. This is the. I changed the name of the type. That was why. That's gonna screw everything up, probably.
Yeah, I think so.
Anyway, I tried my hand at this whole thing and did not go well. Because I'm clearly missing something. But maybe we'll get into that sometime. I don't know. Maybe.
Yeah.
But yeah, so that's the idea, and I made two of them. I made a generic scale degree one, and then a melody one, and let me just move you back over here. Actually, I'll just close you out for a second here. There you go. There we go. So, yeah, so with the scale degree one, I was like, probability of a 1-to-1, it can happen.
Mm-hmm.
1 to 4, yes, it's definitely. I definitely went for the sort of secondary dominant kind of lean in.
Yeah.
So 2 to 5, pretty likely. That kind of stuff. So there was a little bit of a leaning on that, which I think helped to create that kind of circle of fourths sound that you get to a certain degree. But there's always some off chance that you'll get seventh. And then melody, I decided a little bit different approach, but similar. I just had I was just a little bit more judicious about the weird movements, we'll just say. But this part of it, if you were doing like a traditional Markov chain. Yeah, so it depends on. So Johannes says, hold on a second, my frame rate's all wacky right now. Okay, yeah. So Johannes asks, are those weights for different modulations? Yeah. Johannes, you came in late. Yeah, so we're talking about basically a probability table. The probability of moving from one scale degree to another in a chord transition, and then one scale degree to another in a melodic transition. And I ended up using the same one for chords and modal movement. So, yes, to answer your question, yes. But you could create another one, right? And again, I want to emphasize that this is just the way that I decided to approach it. I knew that the harmony mode that I made the other week was going to be handling my inversions, but they were all going to be basically some flavor of seventh, some whatever was based on the modal sort of shift, whatever the modal shift was. But you could absolutely do a more complex transition table, right? You could say, well, what is the likelihood that I would, move from this chord quality to this chord quality, or however you want to split it up. It could be very interesting. So yeah, so again, this would just be very finicky, not impossible, but very finicky to feed as inputs into the meta sound, especially if you wanted multiple instances, right? Like in this case, I had two different tables that I was referring to, which means that I would have to have like 14 float arrays.
Yeah.
You know, it would get a little crazy there. And then the other thing that I did with this particular approach, for better or worse, was I was very rigid about my table structure. So, in other words, it's not just an array of an array. I literally have a struct of 7 float values and a struct of 7 structs of those float values. So, in other words, I created an array of an array effectively, but it's not an actual array. It's discrete float parameters, and the I just use the sort of numerical addressing on them, but absolutely this is not a like normal matrix. It's effectively a matrix, but it's not a norm. And the reason behind that is that I wanted to make sure all of the scale degrees were accounted for every cell. So you couldn't just accidentally give it 8 or 6 or 5 or something like that. Are there any questions about that? How are we doing? Where are we at time? Not bad. One quarter after. Shall I get into the C++ of things?
Yeah, let's take a look.
Let me get... I have a carafe of ice water. Well, no longer ice water. It's pretty hot here. This week it's been pretty warm. So everyone hydrate. You haven't been hydrating. Water. Drink your water. You're human. Presumably. Okay, cool. Oh yeah, and then also if people aren't familiar with data assets are pretty neat. And if you were using this in a system, you could just find it, go data asset, and then I called it diatonic scale degree probability table, and then you got another one. So yeah, and then you'd be like my scale. Yeah. What did I default it as? Oh yeah, I just defaulted it as 100%. And the way that I treated this was a weighting system, and we can look at how I did that. But,
yeah, I was gonna say that seems there's 100% chance of going to every.
Yeah, really, the way that a weighting system works, when you do random weighting like this on multiple elements, is you add up all the values, and then you that's your random range. So in this case, I would do 0 to 7, and then I would and then whatever value, and then what I do is I'd increment through these, and then as soon as I left the range. So if it's like if I 3.5 as for example, like go 1, 2, 3, and then it's like boop over.
Okay.
That's the one. The 3.5 basically lands inside that, and we can look at that how I dealt with that. But that's basically the idea, is that my 3.5 landed inside that value range. And then anything else outside would be outside that range, and so that gives then 3.5 would just result in this 4 scale being selected.
Well, would be kind of cool and maybe kind of weird would be to have like a post edit property change where when you like start everything so it's like equal, right? And then if you drag one of them bigger, it equally decreases all of the other ones, so you maintain like a 1% or 100% probability for like the cumulative. I'm trying to think how that would work out, but
yeah, you wouldn't want to do that, and the reason is that you'd still have to solve it the same way under the hood, and it doesn't actually make the editing experience easier for the user.
Yeah, it'd be like,
because what if you want 2 values to be the same?
Good luck.
Right?
Yeah.
You have to like a lock around them then, like it gets complicated. So yeah, so that it's just easier to have like this loose floats, and I just ended up constraining them to 1, but I don't have to. Like as long as they're
Yeah.
effectively above 0, it works. Although I could adjust my my range, if they incorporated negative. But yeah, so that's but yeah, let's take a look. Which means I'm going to close Unreal down. Yes, I'm going to do that.
Is negative probability a thing?
Well, what I'm saying is that it's negative. It's all relative. It's relative weighting, right? So
Yeah, yeah.
I could offset the evaluation by the negative amount. So in other
Yeah.
words, it's just yeah. All right. So here is the node configuration and my ustruct data. So the ustruct data it allows us to leverage Unreal's property reflection, and so that's what shows up. This thing is what shows up in the data asset. This is what we're looking at: is these actual parameters, and uh, the I actually don't know if that makes a difference. I forget actually if the row base is required for the data asset now.
I think
I
it's
have
just if you want a
forgotten.
data table, right?
I think it's just for the data table, yeah. So I think that was my first idea was a data table that I explored. Um, Regardless, that's what I got. A struct base of the table row base, and then I just have, like I said, 7 discrete floats, and I just named them Roman numerals because that just sort of fits nicely. And then I have this based off the U data asset, and rather than the U primary data asset. The U primary data asset is what you want to derive it from if you want the blueprint version. And then yeah, I just have my scale degree probability table, and then I have 7 of these, and I gave them appropriate scale degree names, and the idea is that this is the starting point and this is the ending point. So, in other words, your sort of y-axis is your from, and then your x-axis is where your destination is, where you're going to. And then down here is the node configuration struct, and that has to be derived from this fella here, the Metasound front end node configuration struct. And it has there's a couple things about it. First, you need to give it a constructor. Then you can add your data. This can be whatever you need it to be. And then here is one of 2 virtual functions you need to override. There are 2 of them total, but I didn't use one of them. The 2 functions that you need to override depend on what you're trying to do. So node configuration allows you to provide data directly from game stuff to your Metasound node, which is why I'm using it here. But node configuration also allows you to configure the node inputs and outputs. And so there's another function, which I'm not going to get into tonight, that you can override to assist in that process. But yeah, so here I have these 2 functions: the constructor and the this get operator data, which implements this operator data interface, and is basically called to provide this shared pointer um, to this operator interface. And if we look at it, yeah, switch over. Here's my function. This is where I'm passing the data from one table to another. Remember, I mentioned that I have like sort of proxy table for the Metasound that's not ustruct based. You can't put a ustruct in the Metasound because it's run outside of the game thread, and so you need your own sort of native structure. If you're just transferring plain old data refers to like sort of normal data types. These data types are already covered, but in my case, I had to basically create my own data type for this. But it wasn't difficult. It was a very easy data type to make. And you can see up here is I basically created it. Here it is. Scalability property by row is I structured it identically, and then the table's a list of rows, and I just have some helper functions. For example, I remember I mentioned that I want to get the total value, so then I just do like here's a function for getting the total from all of the rows, and then here's a function for getting the rows as an array, and then here's the table. Zoom in a little bit here. Here's a table, and then here's like a give me the row by the index that I provide. Some helper functions basically, and this just lets me convert a numerical value to this like actual discrete. Remember, it's not an actual array.
Yeah.
And then it's normal Metasound boilerplate. We get the vertices names, so the input trigger, etc., etc., etc. And then here's the operator data that gets instantiated. So let me just talk back quickly about this sort of relationship here. So here's the actual operator data that gets created. Okay, so this is the actual object that gets used by my node on creation. And if we go back to the struct, remember the struct, this is the U struct, which can contain my U object data. What I have here is this function, get operator data, and it returns not this, it returns this. It returns this.
Right.
And so you can see that down here. So this function is called get operator data, and then what I do is I take my data asset, I create my proxy table, I set all the values on my new table, and then I pass the table in as part of the construction of this operator data object, and then that object is passed in. And I just gave a dummy class for if I like somehow failed, like if the table asset somehow was not valid, because it's a pointer reference, right? I have this basically object pointer reference to this, or this object pointer to this table asset, and so that could be empty. In which case, I just provide it a like vanilla vanilla table, whatever the default values are, is just what you get. So it works. It doesn't break, basically. But then this is what's instantiated, and this data is passed directly into this store here, and it's actually just invoked temporarily during the construction. So, oh yeah, and then we have this lazy name. This has this. Sorry, let me just get some room here. Okay, this has the lazy name. I'm not too hip on, but I think it's allows a different way to invoke this name here. So
There's like a
basically,
limit on how many F names you can have before something bad
yeah,
happens or something. If you hover over the type, it might give you a tooltip on what exactly. Yeah.
lazily constructed F name that helps avoid allocating F names during static initializing. Yeah, so yeah. It's not that I don't know if it's a limit. It's just that they're not free.
Gotcha.
Maybe there is a limit.
I think there is.
Well, it's a GUID. An F name is just a GUID, so there is technically a limit, but it should be pretty high. I mean, it should be like in the billions, but or higher. I think actually our F GUID is 4 32-bit integers, so that should be 100. Like that's basically a 128 bit. So that's like more.
It's not enough. We need
That's-
more.
That's more than like stars in the galaxy. Like that's
Well, we what about the universe?
oh well, that's undefined.
Universe is a big place.
Undefined.
It's not undefined. It's just unknowable by us.
It's yet to be defined. Then how about that? Okay, so here's our operator. And then we just have our, get info, blah, 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 get interface. All this stuff is basically the same, except when I get to create, where is it? Create operator. Boo, 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 boo. Where is my create operator? Wait, where did I? Hold on a second. I just zipped by it. Get default interface, create operator. Here we go. So here's the create operator function, right? Static function that creates itself. Classic. And you can see here, I've got a local probability table. Inside the scope of this if function, I construct the operator data. I get the operator data from the in params. It's actually in param, so it's on the node instance. This function is called, and I get this as basically this type that I defined up above, and I pass into here, and I just use it here, literally inside the scope of this if, just to grab my probability table. This is a function that I defined up here. So if we go back to it, you can see I create a function called get probability table, and it returns the probability table. Easy peasy. So if we return back here, then we have a local version of the probability table that we pass in to the constructor for the actual operator, right? And so then it's passed in as part of the operator uh, constructor, um, and then it's just set directly on a member variable down here. Here's my probability table, and then there you go. And then I have my execute block. My execute block is basically where all the fun happens. And oh, sorry, this is the trigger. So yeah, so when the execute. Here's the execute. This is all just checking for updates. If the scale degree has changed, if the random seed has changed, and then if reset is called, it'll do an internal reset. And we'll look at the random stream here. Let me zoom in. So when you call execute or you call you trigger it. Basically, what happens is we grab the probability table row. Remember, we grabbed the previous scale degree. Then we had that get row by index, right? So the scale degree is counting from 0, so it's 0 to 6 value. That's going to be our sort of first to seventh row. We get the row, and then what I do is I get the total in the whole row. That's my get total. Remember that function above? And so I've got my max random amount. And then what I do is I get an array of remember I had that pass as an array.
Yeah.
And so then I get all these elements as an array. And then I create a new weight range calling random stream frand range. And so and we'll get into random stream, but this is basically the seeded randomization. So I am generating the value on a random stream object. And then the random max is my top range. So I get this new weighting value. And then I have I sort of start out my new scale degree as index none. And then what I do is I go through the table that I had generated up here. Sorry, where is it here? This table. I go through the table, I increment through it. And in this case, I actually, I subtract from the weighting from the new weight. So basically what happens is, in this case, it's the same idea, except I'm subtracting from the value. And so when I hit below a negative threshold, when I drop below 0, I know I've passed my mark and I'm inside that range.
Mm.
And so when new weight drops below 0, then the new scale degree is whatever this index value is. And then I do a check, a sanity check. This will basically cause a crash during development builds. So it should never drop. It should always be above index none. something's gone wrong if it fails that. So basically, that would be if for some reason this had 0 elements in it and it skipped this for loop and indexed none, and then so this is just like a sanity check to make sure nothing crazy happens. But yeah, and then I pass the new scale degree to the output, to my float output, and I trigger my next trigger so that the trigger can pass through the trigger.
Nice.
And so yeah, pretty simple. When I get reset called, I reset my random stream. When my seed gets updated, what I did was I the -1 as the input for a random or a seed was not randomizing the seed. So I basically I do a random seed. If it's -1, I generate a new seed, and that generates its own random seed. If I get a 0 or positive value, then I use that seed and I initialize the random stream with that seed. So that gives me the behavior of like a negative values basically being invalid and just always up, just giving me random output. And then positive 0 and positive seeds will give me an actual consistent seed initialization. And so then yeah, and then this is the normal stuff, all the member parameters here. So not too difficult actually.
Yeah, pretty straightforward.
It's pretty straightforward. And I think so. Here's where are we? We're pretty good in time. So my feeling is, this in this case, it's scale degrees. It could be anything, right? It could be any kind of data. That's why I was talking about. You could be sequencing musical textures that are pre-recorded. You know, and you just decide like what is the most musical or sensible way to sequence these. But you're just sort of managing the range of constraints on your output. Um, and so uh, and so I think this is a way to like to me the data asset is really cool because you can pack a lot of information, a lot of data into a portable asset that can get reused around your Metasound graphs and nodes. Right, that's the other thing is like not just can I use it on different node instances, but I can use it from graph to graph to graph, so I can create consistency. Right, but then also there's a potential there for like maybe a more interesting editor experience, but also I think that it's just a really interesting way to think about how you decide to sequence these complex systems, right? Like you have a lot of data at play, and you have a lot of nuance that you want to exact on the behavior, and you want a way that controls that behavior in a very sensible way. So the Markov chain approach is, I think, a really interesting way to deal with that. But it does sort of assume a kind of format for your data, right? It has to be like that. It has to be codified in some sort of clear, discrete state that you're moving from one to the next, to the next, to the next, or event to the event to the event. Action to the action to action. Something that's very discrete. But yeah. So any questions in terms of the code implementation? I feel like it's pretty.
Yeah, it's a good example for like if you're looking for how to write a Metasound node. There's a lot of good info here.
Yeah. I think that there's if we want to look at the little bit of that the form. One thing that helps a lot with Metasound nodes is giving your Metasound nodes namespaces. Because you're going to be defining a lot of stuff in those namespaces, and you kind of want to constrain them to those names. Something that you don't want to bleed things over to other Metasound nodes, unless it's intentional. So it's a way to sort of manage that. Um, the sort of thing that I've always learned with Metasound design has been to have a sort of to think about the operator as being the top level of behavior, and then anything that's deep gets invoked as like just a regular class or struct that's either defined at the top or defined externally, right? And so in this case, I just had some. It was pretty lightweight. There wasn't anything really deep about this like table. This is effectively just a table. But then yeah, so then you have your vertex names are declared here. And then there's the operator data, which I mentioned. This is you wouldn't. This is only if you're using node configuration. You wouldn't have to do this operator data thing if you weren't doing that. And then you have your operator, and then you have a bunch of sort of collection of static functions. And static functions mean they're global, right? So that means that the system can call these functions without calling the class itself. And so, like for example, you can get node info returns all this information about the node without having to have an instance of the node. It's regardless of the instance. It's global for all. It's basically for the class, right? And then the same thing with the default interface. Here's my inputs of my input of the vertex interface, the outputs of the vertex interface, and those are returned as part of a static function call. And then the create operator node is also returned as a static function call. Though this one actually returns the operator, which is kind of cool. So you like call the operator class and you say create operator, and then it gives you the operator. It gives you an instance of the operator. And so this is where you would construct things, and this is where the node configuration is basically invoked. This rest of it is very boilerplate node configuration. In the I should say, so this is the name declaration for the vertices. You can see here, this is where the actual names are and the tooltips for those names. And then down here on the default interface, sometimes this could be overridden with a get vertex interface call. This actually, you can see this is actual param name metadata. So this actually packages this data in it as part of the macro, and then you can set the default parameter here. So the default value. This is the one I wanted to change to 0. Right there, you go. Meanwhile, yeah. So then you create an operator, and then you have here's the constructor, and so oh yeah, so it's actually something that I wanted to bring up that I haven't brought up previously when we talked about Metasound nodes. So because we haven't really talked about the operator cache, but this is important. So you see that there's a reset function with this reset params. See this guy right here? And then there's the constructor, right? So when you first compile Metasound, this is the constructor. This is called, right? When you first construct the Metasound. This operator is what goes on the operator cache. Mm-hmm. When you retrieve a free operator, cached operator, this reset function is called. So the reset function has to reset all of the things that need to be reused for another instance. So that's an important detail. And so what you'll find is what I often do is I will usually have like my own reset function, which is more like a parameter reset function, which I use and invoke with like an actual reset call. And that ends up being a helper that is invoked by both the reset function here and the constructor. You see how I actually made the constructor and the reset function here the same. It basically calls the same functions. And so in my mind, that means that this will work on the operator cache. You'll get bugs if you don't do this properly.
You have old data from previous instances.
Yeah, exactly.
Yeah.
Yep. Yep. And also you have to have this reset params part of it. Now, one thing that I didn't show here, because this is not an audio processing metasound node, uh, one of the things that you do apply here is in the in params will contain, here, I'll show you actually. We'll just take a look. In params, see this environment? Boop. Wait, sorry, actually, no, not the environment. Sorry, the operator settings. Operator settings. Here's where you get the sample rate,
Nice.
the block rate. So all of the parameters that you need to actually do audio processing have to be retrieved from this in params operator settings struct. And so if I had if I had an audio processing metasound node as an example here, I don't think I have one up here. What do I have up here actually? Yeah, sorry, I don't have anything that's audio processor. But in that case, I would also be caching in these functions. I would be caching that operator data, because you could technically have a different sample rate from metasound node instance to metasound, or sorry, metasound source instance to metasound source instance. You have a different block rate from source instance source. So between instances, your sample rate and your block rate could change, and that would affect how your DSP responds, because all your DSP functions require sample rate information. So that's something that is like that would be invoked in these as well as part of the sort of reset of the operator. The bindings here are binding it to the actual the inputs and outputs to the actual member references. So if we look at the types, we have these sort of nice looking types, which are basically reference types for read or writing. And the idea is that metasound nodes all use reference types because also, like, if this node, this value, this trigger input reference is referencing some other node's trigger output write ref, right? And so it's a way to sort of keep the memory down, so it's not copying triggers, it's not copying buffers, it's not copying these values. All these sort of connected values are referenced from the connected value. So and that's why you can't do a circle. That's what, there you go. That's the secret. That's why you can't do an actual loop. So yeah. That's yeah, and then random stream. Pretty it's I haven't not this is actually my first time using the C++ version of random. I've used the blueprint flavor of random stream. But yeah, it was easier to use than I expected. I just had, initialize it, reset it when needed, generate a new seed, or pass in a seed as needed. And it's been working great. Yeah, and you can kind of hear it, when with the melodies return from A group to A group, you hear that return, and you get the same melody and rhythm. So yeah, there's sort of a lightweight look at a very simple meta sound, I would say. If you want to look at there's some simple audio processing meta sounds. The ring mod, the mid side are pretty lightweight. Let's see. There are some questions from Johannes. Iceland is getting darker. Yes. Hopefully that's not a trend forever. It's just sort of part of the tilt of the globe.
The globe's just gonna keep tilting.
That's right. Oh, that's some trouble right there. Talk about chaos. I mean, it is. It's true. I don't know if it's. I don't know which way we're tilting though. We are. It is
Well,
changing
so
over
the
the
Earth
long
doesn't
term.
actually change tilt. It's just the orientation.
No. The Earth is the Earth. The Earth's tilt is shifting very slowly
Well,
over
oh,
time.
yeah, okay, yeah. The precession of
I just
the
don't. I just don't remember how long it takes and
it's like tens
what
of
the
thousands of years
increment
though,
is.
because that's why the North Star changes after thousands of years.
Aren't we due for like a magnetic core flip or something like that?
Who knows?
All right.
I try to think of things that are, I don't know. I don't want to
Not
say it's
about the
not
magnetic core
important, but
flipping.
yeah, I don't know. That sounds pretty important, but
That seems pretty
it's
important.
just
Yeah.
off my mind, you know.
Johannes says, I've been referencing a great, Anna Lance. Anna Lance used to work at Epic Games. She was support engineer for the audio engine development team. Really great. It was a bummer to see her leave, and I hope she's doing well. Yeah. There are I mean, it is a little bit old. It's a little bit on the older side. There are some changes. It's probably a good idea to do a reference check. Just check some Metasound nodes that are more up to date. Those will probably show a lot more of the like latest. There have definitely been shifts. Like one of the big shifts that we've had over the last a little bit is, sorry, I went too far down. Right here on the registration call, that we used to have an actual like class definition or a declaration, like a full on declaration of the T node facade, and now it's just like a using, and so it's very simplified. Oh yeah, I should also mention here in the register node and configuration, this is how you link the node and the use struct that's defining your node configuration. I don't want to pass. That was a good. That would be like people would know, what am I doing? I don't know how to do this. Is the this is the secret. There's a new registration call and configuration where you include the class of your use struct, which is, remember, this person over here. So yeah. So yeah, it's always a tough one. Tech is constantly changing, constantly evolving, and it's hard to keep up with tutorials. Even the stuff we're doing now is going to age, right? Like that's just the way it is. But that's a good thing. I think that's a good thing.
Yeah, just gotta keep following what's happening. And
Yeah. Cool. Well, I think that's about it from me. Pretty close to time.
yeah, make good time.
We did make good time.
There's a lot
Johannes
of it,
agrees. Good stuff. Did we leave everyone else behind? We still got 5 people here. Still a party. But yeah, I feel like there's untold potential in the data asset thing.
yeah. I'm trying to I'm coming up with ideas in my head, like things I want to try.
Yeah. Don't keep it a secret.
No, it's a secret.
It's a secret.
For now. Gotta sleep on it first.
Yeah, it is something to sort of stew with. I also think it is one of those situations where it helps if you have a specific scenario, like a specific use case where you're like,
Yeah.
oh, I've been trying to solve this problem, or my my inputs are going crazy. I want to like simplify the inputs. Now, the caveat that this node configuration right now it's very early days for it, right? It just came out in 5.6. And it's only it's only available inside the full graph. So it's not something that appears as something overridable in the preset. I think the original thinking was that node configuration was related specifically to topology, and uh, the like ability to sort of inject data into the Metasound node instance was a sort of realization afterward, because the original problem we were trying to solve, by the way, if y'all didn't realize, the original problem we were trying to solve was that like annoying thing where you're like, give me a mixer node, and then it gives you like 16 mixer nodes to choose from. Like that's the problem we're trying to solve, like with node configuration, is that we have like all of these the pin inputs and outputs were determined on the construction of the node, and once you made the node, then there wasn't anything you could do. And so this was a way to sort of influence the construction of the node in advance in a way that was configurable by the node type. And so if your node, now you could like, this is where like hopefully we can it's like a sort of process now where we have to go back through like all the old nodes and like update them to use this new system. But yeah, you can imagine, especially with cat type, you can imagine having a single mixer node with cat input types and cat output type. And then you can configure the number of inputs arbitrarily with the node configuration, right? And the output configuration. And then you could input any type. So you could have stereo, mono, 7.1, all going into the same mixer node.
Atmos.
And then out. That's awesome, right? Like that's the dream. And so that's what the idea was. They were trying to solve that problem, but in so doing, created this opportunity for crazy people like us to exploit.
Yeah, so it's starting to feel that way for sure. No, it's an exciting time for Metasounds to be getting these new features. So
yes. Charles asks, Node Config seems suited to working with Builder. Node Configure is not available on Builder. It will be eventually, but right now it's not. You can't invoke the configuration on Builder nor on presets. So again, I say it's early days, and all of our released nodes that use node configuration, the Epic's released node configuration, are in an experimental plugin, right? So we have the new Metasound experimental plugin. And that's where you'll find these types and these implementations. So if you want like a reference to node configuration, and there's actually something I didn't go into, but it was really cool. It's like a last minute like home run by Helen was to implement a node configuration variant with like a custom widget on the row on the struct. So you can see there's like I forget, it's like configurable float node or something like that, or widget node or something, a widget float node or float widget node. I forget what it's called. And if you'll see on the actual node configuration panel a widget slider that you can just sort of move around, and it sets float parameter on the
that's cool.
on the node. Yeah,
just imagine what we can do with that in the future.
Yes, exactly. This is what it's all about. It's about getting excited for the future. Well, if everyone is sufficiently excited, then I think we can call it.
Yeah,
Call it a couple minutes early. It's pretty good. Well, everyone, thank you so much for joining us this fine evening and/or morning and/or late night in Iceland. and the cold dark night, as Johannes said. Yeah, we'll hope to see you all next week. I don't foresee anything. You got? Are you open next week so far?
Probably.
Yeah, probably. Yeah, we'll see about Aaron. I don't know. I don't know. Yeah, thanks. See y'all. Bye
Have
bye.
a good one.